The last time we reached this page, uh, when you have a lot of missing values in the attributes and the instances, yeah, it will be more complicated to determine which is the MCAR, which are the MAR, which are the MNAR. So, yeah, we will have some ways to handle the missing data. First is to ignore or remove the tuple. Okay. If you remember tuple, what is tuple? Tuple, it is the row. Okay. It is the instance. So the first way to handle the missing data is remove one row. It is usually done when class label is missing. So if we don't have any information about the class label, yeah, we can just remove it. It mentioned that it is not effective when the percent of missing values per attribute varies considerably. So if, yeah, you can see like this one. If there are missing values like this, so it is not effective because we will delete most of the rows. It means in this case, we will delete row number 1, we will delete row number 2, we will delete row number 3, number 6, number 7, 10, 11, 12, and 13. So we will delete many rows. The second method is to fill in the missing value manually. It is tedious. You know, tedious. It is time consuming. So it takes many time to handle data one by one. And sometimes it is invisible. It's not visible. The last one is to fill in it automatically. So if you can fill the missing value automatically, that will be the best. So we will learn those things. Okay. So first, we will learn what is the removal if we delete the cases with missing values. Let's suppose we have these 3 trials. So we have the trial 1, we have the trial 2, we have trial 3. So it is a separate data. We have individual 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we have 10 data. In the trial 1, we have 4 attributes, y1, y2, y3, y4. And among those 4 attributes, this attribute is NA. NA means not available. So it is missing. And then we have 2 attributes here are missing. So if we want to do the analysis, as we know that we can remove the tuple. If we remove the tuple means we will remove the row number 1 and we will remove row number 2 because the 2 of them are missing. Then we will keep the remaining. So how many data do we have now? We will eliminate individual 1 and 2 and we keep 8 multiplied by 4. We have 8 rows, 1, 2, 3, 4, 5, 6, 7, 8. And we have 4 columns, 1, 2, 3, 4. Then we will keep 32 data among 40 data. So we can say that we have 20% loss. How? Because we will remove 8 data among 40 data. Now, if we have the data like trial 2, the NA is only in the Y1. What happened? Shall we delete row like this? Oh, sorry. If we delete the rows, then how many data do you let? Only 4. It's too small. So the alternative is we can eliminate the column. We can delete the column because most of the missing values are in the column. So we don't need this column. We still have 3 different columns. So it is enough. And if you look at the numbers of the data, we can keep 3 multiplied by 10. So we can have 30 data. But if we keep only this one, it means we have only 16 data. So which do you want? Do you want to keep 16 data or do you want to keep 30 data? With this all, we have 30 data. We only need this one. Let's say we delete by rows, then we have only 16 data. Which one is better? Of course, it is better to keep the 30 data. The higher data we have, it is better for our analysis. Then for the second case, we can just delete the Y1. We can keep 30 data, so the loss is about 25%. Now, we have the trial 3. What happened with this one? If you want to remove the row, then you will remove 6 rows. And you will keep only this remaining. Then you will have 4 multiplied by 4, which is 16 data. How about if I delete the column? If you delete the column, then you will have only one attribute. And if you have only one attribute, it's almost meaningless. Only one. What can you do with the analysis? And also, you have only 10 data. So when you want to delete this, when you want to remove the missing values, we need to consider the minimum loss. Okay? You need to find what is the best way so we can keep a lot of data for our analysis. When we want to remove or when we want to delete data, it's easy, but not all data can be deleted. So we need to think if we can let the data survive, we can fill in the data, maybe that will be better. For example, I have this data and I want to fill in the missing value manually. As I mentioned to you, the fill in the data manually, it is time consuming, tedious, and invisible. Let's say I have the data about Brian. He is male and he lives in Yongin, but the data about province is empty. And this is DOB. DOB stands for date of birth. Okay, we can see the date of birth is 12th February. Yeah, maybe this is the day, month, and year. Okay. So the second data is Jessica, female. There is no city information missing. And then, oh, this is not missing. This is something incorrect. The data is not correct. Then what should we do? We know that Yongin is located in the Gyeonggi province. So it is easy. So we can just put the Gyeonggi here. But what about the city? In Gyeonggi, there are many cities. So we are not sure whether he stays in Yongin or in Suwon or in other city. If my database is about the student data, maybe, okay, I can assume that most of the students live in Yongin. Maybe because they live in the dormitory, or maybe they live in a nearby school. So I can assume, because it is the student database, I will put the data Yongin. Or, yeah, you can assume with other. For example, I want to put the capital of Yongin. The capital of Gyeonggi. Let's say I want to put Suwon. Yeah, that's the assumption. Yeah. And of course, that is tedious, time consuming. It is case by case. You cannot do with general way. And you can see this one, it is incorrect. We have only day and month. What about the year? If it is a student database, maybe Jessica has the same year with Brian. So I can just say like maybe. So I can fill in manually. I will put 5 April 86. So it is just to fill in the data to make it complete. So I can do further analysis. The third way is to fill in it automatically. Sometimes, if we don't have anything to fill in, then I can just give a global constant. For example, unknown or new class. Or sometimes we can put a very big value. For example, if I ask, how old are you? And then you do not want to share your age information. So you can put like 9999. It replaces the age values because you do not want to show your age. It's also possible. If you have your data with numerical attribute, sometimes we can replace it with min. If your data is numerical attribute. If the attribute min for all samples belonging to the same class. For example, if you still remember, we learned about the iris data. In the iris data, we have 3 kind of flowers. Iris setosa, virginica, and versicolor. Suppose there is a missing value on the sepal length of the iris setosa. Then I want to fill in automatically. If you use the first way, the attribute mean, then you will calculate the mean from all the flowers. So you will include the 3 flowers, Setosa, virginica, and versicolor, and you calculate the mean for the sepal length. It means we call it the population mean. You want to get the mean from the population, but you can get the mean from the sample. We call the sample mean, or maybe we call the class mean. So I want to check what is the mean of the sepal length in the iris setosa. So I can replace the missing value in the sepal length with only the mean in the iris setosa. So we call this is the mean for samples belonging in the same class. Or we can check the most probable value. We can check with the probability. Some formula like Bayesian, or later we will learn about the decision tree. So for example, the probability of an adult male to get salary 5,000 US dollar. Or we can use mode. Do you remember mode? Mode is the most frequent value. Okay. And we can use this one for the categorical attribute. Now, we have example. Let's say I want to delete the missing value. If I delete the missing value, then I will delete this, I will delete this, I will delete, I will delete, and we have only one data. Okay. If we have only one data, then we cannot do any analysis. So we need to handle this missing data. How can we handle it? Now you have the city. So are you familiar with the city in Korea? Okay, yeah. So in Gyeonggi province, we have a lot of cities. And those are some of the cities in the Gyeonggi province. Suwon, Yongin, Ansan, okay, Songnam. But what is this city? Because there are so many cities, we are not sure. Then I can put a global values or global constants. We call it unknown. Just to put unknown. So for all missing values, we put unknown. That's possible. What about the edge? It is numerical data. So I can make the average. Okay, so this average is 20 plus 23 plus 22 divided by 3. Then we can get a value 21.6 something. Maybe you will ask, Professor, there is no edge with comma. 21.6 years old. It's so strange. But because we use the mean, we use the average. Yeah, you can determine later. Maybe you want to round the value up. It becomes 22. Yes, you can. Or you want to round down, become 21. That's also fine. hobby. It is categorical attribute. What will you fill in of this value? If you look at this variant, we have reading, hiking, piano, piano. So I can choose the mode or the most frequent value. In this case, the most frequent value is piano. So I can just fill it with piano. I assume that this missing value is the same with the most frequent value. And other things may happen. For example, Jessica is a female. So I would like to check what about the hobby for other female. Okay, other female, the hobby is piano. Piano. Okay, then there is a high correlation that all female has the hobby piano. And I can put just piano for Jessica. So that's the probability. Okay, so you already learned here. How many methods are there to handle the missing data? How many? Yeah, 3. The first is to ignore or to remove the tuple. 2, it is to fill in manually. And then 3, it is to fill in automatically. Okay. And when you try to fill in automatically, there are several ways. You can fill in, if the missing value is numerical, you can fill in with min. If the value is categorical, you can fill in with the mode frequent value. When you fill in the missing data automatically, what kind of measure is good for numerical value? Is it good to replace the missing data with minimum value? Or is it good with the maximum value? Is it good to replace the missing value with standard deviation? Okay. Standard deviation is to show the error. So the best measure is actually replace it with min. Okay. Sometimes the minimum okay, the maximum okay, but the best one is min because it can represent the whole distribution. So when you replace the missing value of numerical attributes, the best one is min. When you fill in the missing data automatically, what kind of measure is good for categorical value? Min? Categorical value. You cannot calculate the mean. Can you calculate the median? No. Can you get the mode? Yes. So for the categorical value, we can use mode. Okay. Now let's check the orange. I already give you the data in the e-class. Okay. there is one data. The data name is student data. So you can download your data from the e-class, and then you can open the file, and then you can click this button. So it will give you the folder name. So you can get where is your data. So in this case, I'm putting this data in this folder. So I click on the student data, and then I open it. Okay. So I'm not sure about your audience, but maybe in the first time, your data is like this one. Am I right? Yeah. So the name, city, and hobby has been detected as text. If you use the text like this one, you can open the data table. When you look at this, you will see that the three columns, name, city, and hobby, appear in the gray color. So the gray color means something that you cannot do further at all. It is only text. Yeah, we will learn more how we deal with the text. But in this case, we need to change. For our class, I think it's better to have to focus only to the two type of data, categorical and numeric. So you can change this into categorical. You can change this into categorical. And then there are some options here. You can put the role of the attribute, whether you want to put it as a feature or you want to put it as a target or as a meta or skip. Meta is just information. So you cannot do any further analysis. So I will choose feature. When you use feature, then the column now becomes white. Now it becomes something that we can analyze. Same with the other attribute, you can choose with features and categorical. And then you can click apply. When you open the data table, then you will see now the column name, the column city, and the column hobby. There is no gray color. And if you look at this data, there is question mark. What is the meaning by question mark? This one, question mark, question mark. The data is missing. Okay? So if you look at the data in the original file, if you open the student data.csv, so the data is missing. It is blank. Okay? We call this is missing data. So when you look at this one, Python or the orange automatically show it as question mark. Now we need to handle this one. Let's say we have preprocess. So you can make a new widget preprocess. Okay. So in the preprocess, there are some functions. You can do discretize, you can do continuize, you can impute, you can select relevant features, you can select random features, and so on. And so those are the functions that you can do later. But for now, let's choose the impute missing values, because I want to do something for the missing values. Okay. So in the pre-process, there are three methods. The first is average or most frequent. So if the data is numerical, orange automatically calculate the average. But if the data is categorical, orange automatically find the most frequent. What about replace with random value? So orange will determine any value to fill in the missing value. What about remove rows with missing values? So one row will be deleted when orange find any missing value. So let's choose this one. You can look at this data table. So only one remains because we remove the missing values. We remove the missing value and 4 rows have missing values. So we have only one. If you change with the average or most frequent, then you will keep all the data and the missing value has been replaced. You can see that this age is 21.67. I think this is the average of the age. And the missing value here, okay, orange changed it with Hansan. Maybe because it automatically select any random data, and the most proper data usually it's stuck with the letter. So A is the first. So orange choose randomly. And then Jessica, yeah, we have missing value on the hobby, but now it has been replaced with piano. Piano is the most frequent value. The next is, I would like to explain about impute. Okay. What is impute? Actually, impute has the same meaning with this preprocess to handle the missing value. You can select the widget impute. Okay, restart this one. When you do the impute, it means you want to do something for the missing value. Don't impute. Don't impute means you do not do anything. Okay? You did nothing. So just keep the missing values. Average is the same with the previous one. You will calculate the average if it is numerical. The most frequent will be done if the data is categorical. And then as distinct value. So we will make a distinct value to replace the missing value. Fixed values. So you can put a fixed number or a fixed value. Model-based imputer. We can use simple tree. Yeah, we will learn about the tree maybe in a few weeks later. Or we can put random values. Or we can remove the instances with unknown values. So those are the options. This method is the default method. So when you choose this one, it will work for all the attributes. When you choose this one, it will work for all attributes. If you choose random values, it will work for all attributes. Okay, so this is the result of the random values. But let's say I just put this do not impute, and I want to make a very specific method for each attribute. For example, for the age, I would like to use the average. So you can click here. The age will be average, and I know that there are some missing values in the city. So for the city, I will give a distinct value. And I have also missing value in the hobby. For the hobby, I would like to use fixed value. So I can put, let's say I want to put hiking. Then what we have here is every attribute will have different way to handle the missing bit. Okay. If you look at the result, so the age will be replaced by the mean. The city will be replaced with NA. What is NA? Not available. Okay, thank you. So we the NA is similar with the unknown. Orange changed with NA instead of giving the question mark. And then Jessica, the hobby now becomes hiking. Before we used the most frequent value, but now it becomes hiking because we give a fixed value which is hiking. Okay. I'm sorry, I will skip this one because I will explain another detail about this integration. Okay. Any questions? No. When we want to do the data cleaning, we call this is the data cleaning. The first, when we do the data cleaning, we handle the missing value. When we do the data cleaning, we can also do something for the noisy data. You know, when this place is dirty, we can clean it. So the same, if we have the data which is dirty, we can also clean it. Now the dirty data, we call it noisy data. It can be caused by a random error or any variance in the measured variable. For example, I want to measure the apple, but when I measure the apple in this way, it becomes minus 200 grams. Something wrong with the tooth. This is noise data. The noise, it is the incorrect attribute values. So the value that is not correct, the value that is not in the distribution. It can be due to the faulty data collection instrument. It can be because of the data entry problems. It can be the data transmission problems. Maybe the internet connection is not good. It can be the technology limitation or inconsistency in naming convention. There are some ways to handle the noisy data. First is binning. Binning means we will sort the data and do partition into pin. So we will check what is the meaning by pin. After we have the pin, we can smooth. We can smooth it by the means, or we can smooth it by the pin median and etc. So we will look at this one. Regression. We can smooth the data by fitting the data into the regression function. Regression, it can be like this one, the linear regression. So if the value has the small error with the function, we will use it. But if the value has the high error with the function, then we will remove it. Clustering. We will learn later. Clustering is to detect and remove outliers. Or we can combine the computer and human inspection. So detect the suspicious value and check by human. So human and computer should have interaction or should do the same method to correct whether it is outlier or not. Okay, we can use the simple discretization by pinning. You know, discretization. Discretization. Discrete. What does it mean by discrete? This is the categorical value. So you want to change from a numerical value into a categorical value. Let's say I have 8. I have 8. Maybe the age is 20. And then 23, 24, 26, 30, 41, 45, 51, 55, 67, 75, 80. Okay. So it is difficult to check what is the meaning by this age. So I can make a discrete value. I can split maybe like this one. If the person has the age below 50, I can say the category or the class is young. If his age is more than 50, then he is old. So we can say this is the discretization. This is the very simple one. In the tuning, we have two ways. Okay. We have equal width and we have equal depth. I will explain by examples. This is the sorted data for price. In dollars, okay, we have 4, 8, 9, 15, 21, 21, 24, 25, 26, 28, 29, and 34. This is the minimum. This is the maximum. Okay. I want to partition into equal frequency or equal depth. So let's suppose I want to make 3 pins. 3 pins, you know, pins. We want to make the data into 3 places. Okay. So we have 3 places and I want to put the data. Where should I put the data? Now, if I use the equal frequency, it means for every pin, it should have the same frequency. How many data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 data. If we want to have equal frequency, then every pin should have 4 data, and 4 data. Then for 8, 9, 15, it will be in the first bin. 21, 21, 24, 25, it will be in the second bin. 26, 28, 29, and 34, it will be in the bin number 3. So we call this is the data in the pin number 1, this is the data in the pin number 2, and this is the data in the pin number 3. If I want to do smoothing, what is the meaning by smoothing? So I want to make the data based on some methods. Let's say I want to smooth this data by means, by pin means. So I need to check what is the mean of this pin. 8 plus 4 plus 9 plus 15. So the mean is 9. Then every data I will change to the mean of that pin. What is pin number 2? 21, 21, 24, 25. So I will replace, so I can get the mean is 23. So I will replace every data here with 23, with the mean. Pin number 3, we have 26, 28, 29, 34. So we will replace this with the mean. So I can say the mean is 29. Okay. Now I would like to check with smoothing by pin boundaries. Smoothing by pin boundaries means I would like to change this value based on the nearest minimum or the nearest maximum. That's it. 4. 4 is the minimum. So I will just keep this 4. What is 8? If you look 8, is it nearby 4 or is it nearby 15? 8 to 4. So we have the distance 4. 8 to 15. We have the distance 7. So which one is closer? 4. Then we put the second data 4 because the closer value is to the minimum. What is 9? Is it closer to 4 or is it closer to 15? 9 to 4, it is 5. 9 to 15, the distance is 6. So it is closer to the minimum. Then we choose 4. 15 is the maximum. Of course, we will choose the maximum. And we have the 21 because this is the minimum. 21 is the minimum. 24. 24 is nearby the maximum. Then we change this to 24. And this is the maximum. We have 26, 26, 26, 34. 26 is the minimum. 28. It is nearby the minimum. 29. Nearby the minimum. Then we have 26, 26, 26. And 34 is the maximum. So we just make it as the 34. Okay. So what about the equi-width? So let's say I want to make 3 pins. Okay. Based on the definition, divides the range into n intervals of equal size. So we have n. Let's say I want to distinguish into 3. Okay. If A and B are the lowest and the highest value of the attribute, so A is the lowest, B is the highest, the width of the intervals will be W, equals to B minus A divided by N. So what is the maximum? 34. What is the minimum? 4. And how many bits do I want to get? 3. Then 34, this is the maximum, minus 4, which is the minimum. So this is the B, this is the A, and then we divide with the N, which is 3. So the width will be 10. What does it mean by this 10? I will make a difference of 10. The minimum is 4. So I will make the width 10. 4, 5, 6. So 4 is the first. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It means 4 until 13 will be in the pin number 1. 14 until 23 will be the pin number 2. And then 24 until 34 will be in the pin number 3. So let's check. 4. 4 is in between 4 until 13. So it will be in the pin number 1. 8. It is in between 4 until 13. It is in the pin number 1. 9. It is also in the pin number 1. 15. Oh, it is in the pin number 2. 21. It is in the pin number 2. 21. It is in the pin number 2. 24. It is in the pin number 3. So the remaining will be in the pin number 3. So that's the meaning by the equi-width. Okay. So it is straightforward, but outliers may dominate the presentation. And skew data is not handled well. So if you can see here, so most of the data are located in the 24 until 34, 24 until 34. So the pin number 1, we can say it is something like line. And the equi-depth, it divides the range into n intervals, and every pin contains approximately same number of samples. It is good data scaling, but when we manage the categorical attributes, it can be tricky. So usually this kind of pinning is good for the numerical attributes. So this is the equal frequency, equal depth. Okay, I will stop first. Let's have a break. Okay, I will continue after the break.